So this is 4.4b, College Algebra. We are working on example 7 right now, so let's go ahead and get that down. So we've got 5 log of the base b of x minus log base b of y plus 1/4 log base b of z. Okay, so it's all spread out, it's expanded. And what they want us to do is write this as a single logarithm. Okay, so let's get started. First thing we're going to do is we're going to put our exponents back on. So put that back on. Didn't do anything here. And we put a z to the 1/4, which is actually a 4th root. Okay, next thing we're going to do is we are going to look at our division. Our division says we're just dividing those. Like that. And then leave the rest of it alone. Okay, this plus sign says we multiply. X to the 5th, z to the 1/4 over y. And you can be done there, or you can take that z and change it to the 4th root of z if you'd rather be working with radicals. And that's it for example number 7. Okay, let's jump to 8. Okay, so for example 8, they give you these two equations. Log base a of 2 is a number close to 0.301. Log base a of 3 is a number similar to or close to 0.477. And you're supposed to find each of the following. A says find the logarithm given a base a of 6. Okay. Can I look at either one of these and get me any information to solve this? No, but I can change this to 3 times 2, right? Which is the same as log a of 3 plus log base a of 2. Now, log base a of 3. Ah, it's right there. Log base a of 2. It's right there. Add those two together, and I get 0.778. So, you see what I did? I'm given this information up here, and this is the problem, so I'm going to try to make this look like these two. So, let's look at B. Log a of 2/3. I'm going to write this as log okay, and lo and behold, I've got this here 0.301 minus 0.477, and then that gives me negative 0.176. Alright, let's keep going. Let's look at C. Log a 81. This takes some finagling to figure this out. You're going to have to do some work. All I know is I need this to be a 3, right? And that's the 4th power. So this is actually going to be 4 log a 3, and that is what I'm looking for because I have that here. So 0.477 times 4 is what I wanted to do there. Okay, so let's go down to D. D is log a, and this takes a lot of practice to get to the point where you can look at these and be like, oh yeah, I can do that. I can figure out a way to make that happen. So 1/4, what am I going to do with the 1/4? It's divide, so I minus. Okay, does that help me out? Nope, that doesn't help me out at all, except I know that this is equal to 0 because a to what power equals 1? Well, if x is 0, then that works. And that's one of the properties you've learned. This could be written as log a to the 2 squared, right? And then if we take this 2 and move it to the front, we get 0 minus 2 log a 2. And this here is from up here. So I have 0.301 I can put in place of here times 2 with a negative on it. Okay, and that gives me that part. Okay, let's look at E. Log a of 5. Oh goodness, what am I going to do with that? Can't do anything with it. Okay, I can't split this up to a 2 plus 3. Okay, that doesn't work. Can't do that. So I end up with just saying, nah, nothing. Can't do anything. Alright, let's look at F. That's the log a of 3 over log a of 2. Okay, that isn't too terribly difficult because the log base a of 3 is 0.477 and this one is 0.301. So I just divide that out and I'm done. Okay, two final properties to look at. One looks like this. Okay, that's what that equals. Okay, so if we were to write this in exponential form, it would be a to the x equals a to the x. So yes, I know that's a true statement. Okay, so that works. If I can get my logarithm simplified to a certain way, then it will really end up helping me because this whole thing here, if I can get it written this way, is going to equal whatever this exponent is. If this is an a and or these two numbers are the same, then my answer is going to be whatever my exponent is. Alright, so that's basically what that says. And so for instance, let's look at log a 8. That just equals 8. If I have ln e negative t, if I were to change this to logarithmic form, it would look like this. Or I'm sorry, into common logarithm rather than natural logarithm. Because remember, ln is the same as log base e. Okay, and that would give me as an answer negative t. Okay, c, log, and I've got a base of 10 and 10 there, and that is a 3k. And so this actually is log base 10, 10, 3k, and that equals, oops, not 3 to the k power, 3 times k. Both of those are the exponents. Okay, a final property here is if we have an a and we have the log in the exponent position with a base like that, that is going to equal that. So this and this have to be the same, and then this here is actually your answer. Okay, so for instance, and I have to write these bigger because it's real hard to write real small on this iPad. Okay, so my answer to this is just k. E to the ln of 5. that can be written as e to the log base e of 5. So that means, because that and that are the same, we get 5. And let's see, A, B, C. I'm sorry, I'm getting really tired. It's getting really late. Oops. Yeah, I must be getting tired. I can't even write the problem down. Log is in the exponent position with a 7t. Alright, so remember, there is always, when there isn't a base, there's always an assumed 10 there. And you get that. And that's it for 4.4. If you look at the top of page 396, there is a summary of the properties. I would suggest you write all those in your notes, because those are going to be very important for you to remember. And that's it for 4.4.